So guys, now we are going to discuss some important questions. These questions were there in some of the competitive exams, and in this chapter many of the questions are actually based on the trend involved in periodic properties. So here we are going to discuss some questions. For that purpose, the thorough knowledge of H block element, rather the trend involved in a periodic properties, and some of the compounds which we have discussed, there are some important properties we should know. So if we go for the first question, the correct order of increasing thermal stability of K2CO3, MgCO3, CaCO3 and BeCO3. So we are going to write here the correct order of thermal stability. Thermal stability means after heating it undergo decomposition. So which carbonate undergo decomposition very easily and which will not? So that we have to discuss here. So answer for the first question, we know that alkali metal carbonates are highly stable. They never undergo decomposition. It is because of their high lattice energy, and therefore K2CO3 has the maximum thermal stability. Now, in this case, if we consider the thermal stability for the alkaline earth metal goes on increasing as we move down the group. So the correct order for the thermal stability is K2CO3 maximum thermal stability, then CaCO3, then MgCO3, then BeCO3. This is covalent, hence it can easily undergo decomposition. Ionic, the ionic strength goes on increasing, and therefore the ionic characters goes on increasing moving down the group. Therefore calcium carbonate is more stable. It decomposes something around 1000, greater than 1000 Kelvin. Next question. The solubility of alkali metal hydroxides of, so these are the compounds given to you: lithium hydroxide, sodium hydroxide, cesium hydroxide, potassium hydroxide and rubidium hydroxide. What will be the correct solubility order? Okay, so which is more soluble, which is least soluble? Now we know that lithium being a smallest size, and because of the Fazan's rule, the bond become covalent, or it has a more covalent characters. Because it has a more covalent character, it is partially soluble in water. As we move down the group, the ionic characters goes on increasing, and therefore solubility of these metal hydroxide also goes on increasing. So the correct order of solubility is lithium hydroxide least stable, least soluble, then sodium hydroxide, then potassium hydroxide, then rubidium hydroxide, then cesium hydroxide. So CSOH will be the strongest base because it almost dissociate completely after solubilizing in a water. Next question. Which of the following chloride do not impart color to the flame? As we know that the compounds of alkali and alkaline earth metal imparts color, but not all. The color is because of the presence of unpaired electrons and the low ionization potential of these metals. But in case of alkaline earth metal, first two members, beryllium and magnesium, do not impart color to the flame. The reason behind it, they have a very high ionization potential. Since they have very high ionization potential, the energy required for the excitation of electron is not lying in the visible ring. So the excitation of electron is taking place, but that is not in a visible range, and therefore those compounds do not impart color to the flame. Hence, the answer for this question, BeCl2 SrCl2. So BeCl2 will not impart color to the, but SrCl2 will impart color to the flame because of the low ionization potential. BeCl2 MgCl2, yes, both will impart color to the flame because they have very high ionization potential. Very high ionization potential, so the electron is tightly held by the nucleus, and therefore the excitation of electron is not taking place in a visible range. Hence, the answer is B. Give the trend for the ionic mobility of following ions in the aqueous solution. So, here if we dissolve the salts, there is a formation of ions in the aqueous solution. Now, these ions are then hydrated by water molecules because water is a dipolar solvent. Water is a polar solvent. Because of the polarity and has a certain dipole moment, these ions are now surrounded by the water molecules. Therefore, we can say this way, the ionic mobility is actually depend upon the hydration, the extent of hydration. Greater the hydration, lesser will be the ionic mobility. Obviously, since the hydration is more, the more ions are covering the metal ion, and therefore the mobility is restricted by these water molecules. Less hydration means more ionic mobility. So, the least mobility is for Na plus, then comes K plus, then Rb plus, and then Cs plus. The highest ionic mobility is associated with Cs plus. Okay. Give the thermal stability of alkali metal hydride. Again here thermal stability, when I am talking about thermal stability, it undergoes decomposition giving you metal and hydrogen gas. Now interestingly, the thermal stability here depends upon the bond strength of metal and hydrogen. So as we move down the group, atomic size goes on increasing, therefore bond length goes on increasing. So bond strength goes on decreasing. So LiH bond is a strong bond while CSH bond is a weak bond. Obviously, the thermal stability therefore goes on decreasing as we move down the group. Therefore, the correct order of thermal stability here is LiH is the most stable, then NaH, then KH, then we have RBH and cesium hydride. So bond length is greater in case of cesium hydride. Okay. Now the next one, K2CO3 cannot be prepared by Solvay ammonia process because the options are K2CO3 is a fairly soluble in water. Second option, it has no water of crystallization. Third option, KHCO3, potassium bicarbonate or potassium hydrogen carbonate, is highly soluble in water, and K2CO3 decomposes in water. Now for that purpose we have to recall the Solvay's process. In a Solvay's process, actually how are we proceeding? We are actually treating brine solution with, that is sodium chloride solution, with ammonia and carbon dioxide, so that it will give you sodium bicarbonate. Now in case of sodium carbonate, the precursor is sodium bicarbonate, which on further heating gives you sodium carbonate. Now in case of sodium bicarbonate, which is sparingly soluble salt, which is less soluble in water, therefore it will precipitate out, and after precipitation, sodium bicarbonate, which we are getting as a residue, and drying and on heating gives the sodium carbonate. In case of potassium carbonate, the precursor is potassium bicarbonate only, but that potassium bicarbonate is highly soluble, and since it is a soluble, it is very difficult to recover it in a solid state. Therefore, potassium carbonate cannot be prepared by solvay ammonia process. Okay, so here I can write this way: potassium bicarbonate is highly soluble in water. So that is our option C. Okay. Therefore, it is very difficult to recover potassium bicarbonate, cannot be recovered in a solid state and in pure form. Therefore, we are not using solvay ammonia process for the preparation of potassium carbonate. Okay. Next question. For alkali metals, which of the following trend is incorrect? So these are some trends given to you. Hydration enthalpy. We know that hydration enthalpy is inversely proportional to atomic size. So as we move down the group, hydration enthalpy goes on decreasing. So this is a correct trend. Ionization enthalpy is also inversely proportional to atomic size. So again, as we move down the group, ionization enthalpy goes on decreasing. So this trend is also correct. In case of density, actually density depends upon atomic mass and atomic volume. Now at one point of a time, atomic mass always overcomes the atomic volume, and therefore density goes on increasing. So in this case, general trend must be lithium atomic mass is small, cesium atomic mass is large. So there must be high density for cesium and low density for lithium. It is true up to sodium. Means in case of, so this is a next question, question number 7. Okay, here the incorrect answer is density. The correct trend is like this way. The density of lithium is less than sodium, but is greater than potassium, which is further less than that of the rubidium. Okay, so there is a deep in case of potassium where the atomic mass cannot overcome the atomic volume, and therefore density of potassium decreases. Okay. Next one. Hydration enthalpy of Mg2 plus is greater than that of. Now let us consider the position of magnesium now along with these ions. So here we have a Li plus, then we have Be2 plus, okay, then we have Na plus here, and if we consider magnesium is over here and aluminium is over here. So as the charge increases, atomic size decreases. So it is obvious that, and at the same time moving down the group, atomic size increases. So if I consider this trend here, so and if I consider this trend, so aluminium is smaller than magnesium. So hydration energy of aluminium is greater than magnesium. Atomic size of beryllium is less than that of the magnesium. So hydration energy of beryllium is greater than that of the magnesium. The atomic size of lithium and magnesium are almost same. So obviously their hydration energy must be almost equal. Okay. But in case of sodium, the atomic size of sodium is greater than that of the magnesium. So obviously hydration energy of magnesium is greater than that of the sodium, and therefore the answer is B. Okay. Now next question. Which of the following metal oxide is or are ionic? Now as we know that moving down the group, ionization potential decreases, electropositivity increases. So in case of alkaline earth metal, beryllium oxide is less electropositive and the further elements are more ionic. Therefore, here answer is magnesium oxide, calcium oxide and strontium oxide. So multiple answer correct. Okay. So here these three oxides are ionic in nature. Next question. Now this is one question maybe asked in a comprehension type questions. Now such questions will be there which is in combination with salt analysis also, because there are certain salts which we are using in a salt analysis and they have particular test also. So those questions are always combined with the S block element. So it is necessary to understand that part. Okay. Compound A on heating gives a colorless gas and a residue that is dissolved in water to obtain B. Excess of carbon dioxide is bubbled through aqueous solution of B. C is formed, which is recovered in a solid state. Solid C on gentle heating gives back A. So the compound A. Now here if you read the options, A CaCO3, B Na2CO3, C K2CO3, D CaSO4 2H2, automatically two options get cancelled because these two options never undergo decomposition on heating alkali metal carbonates. So now we have two options, calcium carbonate and CaSO4 2H2. So if I heat this CaSO4, it will decompose to CaO plus CO2. So we are getting carbon dioxide. Now that excess of now what we are doing, that calcium oxide is dissolved in water, so that we are getting calcium hydroxide, through which we are passing carbon dioxide, we are getting a precipitate, which on drying, recovering, so white precipitate if we are getting, and if we are heating it, so the water of crystallization will remove out and we are getting calcium carbonate again, that is A. In case of CaSO4 2H2O, if I consider that will be the answer, if I heat it, what will happen? It will lose water of crystallization and we are getting a solution of calcium sulfate. If we pass carbon dioxide through it, nothing will happen. Therefore, the answer is A. So, write the reaction. CaCO3 on heating gives you CaO plus CO2. So, this is removed. Now, this CaO further dissolve in H2O, so that we are getting CaOH twice, calcium hydroxide. Now, through this we are passing carbon dioxide, so that we are getting CaCO3 aqueous, which on heating, drying gives you CaCO3 solid. So, such kind of a questions will be there from S block element. So, remember that in case of S block element and whenever we will see the P block elements also, we need to know the salt analysis part also, because many of the reaction part is actually coming from that chapter, qualitative analysis. But there are certain questions like question number 1, 2, 3, 4, 5, 6, okay, 7th, 8th, they are actually based on what? They are based on a periodic property. So it is necessary to understand those properties and relate those properties. try to figure out the exceptions, like here in case of density. And why is that exceptions are there? Otherwise, in many of the periodic properties, the elements are following general trend. So that will be the simple. If you make a proper flow chart, this chapter is very simple and short also. Okay, that's all about the S block element. The other part of the S block element, that is the concept of hydrogen, we'll discuss in a next session. Thank you very much.